Hello everyone. Today we'll take a look at a question of maths which came in JEE Advanced 2017. So the question goes as follows. Let f of x is equals to x plus nl natural log x minus x ln x in the domain x 0 to infinity. Column 1 contains information about the zeros of f of x, f dash x and f double dash x. Column 2 contains information about the limiting behavior of f of x, f dash x and f double dash x at infinity. And column 3, information about increasing and decreasing nature of f of x and f dash x. So basically this is a question in which there are 3 columns and there are four points in each column, and we have to find the correct combination. So let us just write down what is given in this question. The f of x function given in this question is x plus ln x minus x ln x in the domain which is 0 to infinity. This is a domain. Now let us calculate f dash x because we'll need to analyze for each of the columns. So it is better to calculate first hand. Minus using chain rule 1 upon x into x. So f dash x is 1 upon x minus ln x. F double dash x will then come out to be minus 1 upon x square minus 1 upon x, which is nothing but negative of 1 upon x plus 1 upon x square. Now since we need to analyze for a lot of columns and for a lot of columns, as we can see, column 1, column 2, column 3, we have 4 points in each one. Let us just, I think we can analyze this question graphically, and I think that will be easier. So let us try drawing the graph of f of x, rough sketch basically. So let's draw y-axis, x-axis. In this question, we'll see that the points in which in between from which we need to analyze is basically x is equals to 1, x is equals to 0 and x is equals to e square. These are the points around which we need to analyze this function. So let us just put in the value of f of x near 1. Let us see what is the value of f of 1. F of 1 comes out to be 1 plus 0 minus 0. So f of 1 is 1. So f of 1 is 1. This is the graph of f of x basically, right? F of 1 is 1. Then now let us see for f of e. F of e comes out to be e plus 1 minus e times 1, which is again 1. So f of e is also 1. Now another point which we will be needing to analyze this function is e square. So f of e square is e square plus 2 minus e square into 2, which is nothing but 2 minus e square, which is, as we can see, a negative value. So f of e square is somewhere down here, a negative value, right? E square 2 minus e square, this is 1. Now these are the points from which f of x will pass through. Now let us analyze this function f dash x, its nature and all. Now for f dash x, let us start putting in values. Let us see f dash x for value 1. X is equals to 1. 1 by 1 minus 0. So f dash 1 is 1. F dash e is 1 upon e minus 1, which as we can see is less than 0. And f dash e square is 1 upon e square minus 2, which then again is less than 0. Now let us draw the graph of f dash x. Let us analyze the graph of f dash x and its roots. In f dash x we have two functions basically, 1 upon x and ln x, and in this question we need to analyze the roots, where the functions are the derivative of the functions and the double derivatives of the functions, where they go 0. So basically we need to just see where their roots might lie. So yeah, let us just draw 1 upon x. This is 1, this is 1. So the graph of 1 upon x is passes through 1 and is somewhere like this. And the graph of ln x is like this, passes through 1, which is very basic and we all know. At E, ln x's value is 1. So this is the graph of ln x, this is the graph of ln x, and this is the graph of 1 upon x. So as we can see, ln x goes to minus infinity as we approach x is equals to 0, and as x goes to infinity, ln x goes to infinity. And for 1 upon x, as x goes to 0, it goes plus infinity, and as x goes to infinity, 1 upon x tends to 0, right? And it is very clear that these functions, this f dash x function will only go to 0 at this point, this particular point. Somewhere around here, f dash x will be 0, and and f dash x will be greater than 0 for all of these points on this side of the graph, and f dash x will be less than 0 for all of these points, because it is very clear that ln x in this portion of the graph is much greater than 1 upon x. 1 upon x is just this much, and ln x is this much. So if we subtract ln x from this part, which 1 upon x, it is very clearly that it is negative value. So this is how we can say now. So going by this graph, we can say that since f dash x is 0 somewhere around 1 to e, and we also know that these are the points from where the graph of function is going to pass, and at f dash x is equal to 0, we have slope equal to 0. So somewhere around here, function will pass through, and f dash x is greater than 0. This means for this portion of graph, the function is increasing. So the graph will look somewhat like this, and starting from here, f dash x is less than 0. So once it crosses this point, the function will be decreasing, and the value here, the function's value is 1 here, and it is somewhere negative here. So the function passes through like this, right? So this is somewhat the rough sketch of the function x. So now we can start analyzing the questions. So for column 1, now column 1 says that f of x is equal to 0 for x 1 to e square. So 1 to e square, what is 1 to e square? 1 to e square. Now it is very clear that f of x will be 0 for a point between 1 to e square, which is this point. So column 1's option 1 is correct. Option 2 for column 1 is f dash x is equal to 0 for sum x 1 to e. For sum 1 to e, we have already analyzed that f of x will be 0 because the values of these two functions are equal. This function 1 upon x and this function ln x, they meet at this point. So basically we are going to have f dash x is equal to 0 for this point, which is somewhere which lies between 1 to e. So second option is also correct. Now the third option says that f dash x is equal to 0 for some 0 to 1. Now it is very clear that for 0 to 1 it is always positive and it never will be equal to 0. So this third option is incorrect. And this fourth option says that f dash x is equal to 0 for some x 1 to e. F double dash x is equal to 0 for some 1 to e. Now f double dash x is this value, right? F double dash x is nothing but this value, and it is fairly clear that this will always be less than 0 for all the positive values of x. If we put any positive value in 1 upon x plus 1 upon x square, this part will always be greater than 0, and which is multiplied by a negative sign, which concludes that this will always be less than 0. So fourth option is basically also incorrect because it will never be 0 and it will always be less than 0. So this clears column 1. Now let us go to column 2. Now in column 2 we have limit f of x for x tending to infinity equal to 0. So for limit x tending to infinity, this function, as we can see, goes to very clearly minus infinity, right? The function is decreasing, it has a negative value, it goes further down, so it cannot be 0, it goes to infinity. So the first option is incorrect, and the second option, which actually states that the function goes to minus infinity, must be correct. Third option states that f dash x is equals to 0, f dash x is equals to minus infinity for x tending to infinity. Now yeah, so basically this term is also correct because f dash x is less than 0 for all the bigger points of x, so third option is also correct. It will go to minus infinity. And the fourth option states that f double dash x for x tending to infinity is 0. Now as we can see that f double dash x, right? F double dash x for x tending to infinity, limit x tending to infinity minus 1 upon x plus 1 upon x square. Now for x tending to infinity, this term goes to 0, this term also goes to 0. So yes, 0. So fourth option is also correct. Right? Now let us go to column 3. Column 3's first option asks you, which is the P option, f is increasing in 0 to 1. For f to be increasing, we know that f dash x has to be positive. For 0 to 1 they are asking, so let us see for 0 to 1. Now it is very clear that the function is increasing from 0 to 1. The function is increasing from 0 to 1. It is further verified, as we can see, the value of the derivative of the function is greater than 0 from 0 to 1, right? So the first option is correct. The P option is correct. Now Q option, f is decreasing in e to e square. F is decreasing in e to e square. From e to e square, it is fairly clear, e to e square, it is fairly clear that the function is decreasing, and also the function's derivative value from e to e square is negative. So the function is decreasing. So Q option is also correct. Now we can actually solve the question by these results only, but let us further solve for R and S. We don't need to solve R and S. We can get a unique options value, but still f dash x is increasing R says that f dash is increasing in 0 to 1. So for 0 to 1, yeah, so f dash is increasing. Okay, so the calculations which we have performed up until now results in column 1 stating for the first point of the column is correct, column 1 is correct, second is correct, third is incorrect, fourth is also incorrect. In the second column, first is incorrect, second is correct, third is correct, fourth is correct, and in the third column P and Q are correct. Now with these calculations we can already find out the answer. So the option 1 states fourth, the option 1's combination is fourth for column 1 column 2, column 3. So 4, 4, S. Now we already know that 4 is incorrect, so this we can already eliminate. Option B states that second Q. Now second is correct, and second is again correct, and Q is also correct. So B is the correct option. We don't need to check. So this is a multi-correct question, so we'll need to check for the other options too. So for option C, 1P, 1 is correct, 1 is not correct for the column 2, so we can eliminate this option. Option D, 3R, 3 is incorrect in option column 1, so we can eliminate this option as well. So our final answer is option B.